Hey guys, this is for homework help on your assignment, page 206, 27 through 31 odd, 34 to 38 even, 43 to 47 odd. And I won't be doing all of them, but I'll do one in this section, one in here, and I believe two in this one. So we'll get a good half of them done total. So I have a blank sheet of paper out. A couple of them you need to graph, so I also have graph paper out. Pause the video if you need to get either of those things. When you're ready to roll, hit play and we'll begin with number 29. So with number 29, I'll give you a minute, 30 seconds here to write down the problem. You are given the quadratic equation y equals 2x squared minus 5x plus 12. And to get participation points for today, I need to see that written down, and then make sure you label these. This is the A, -5 is the B, and 12 is the C. So our general or standard form of a quadratic is y equals ax squared plus bx plus c. And the A and the B and the C tell us everything we need to know about the graph. When it says in vertex form, you need to know what that is. So I'm going to write the vertex form over here, and we'll box it in just a minute. Vertex form is, this is standard form right here. It's a y equals ax squared plus bx plus c. Vertex form is a times x minus h, and again you should write this down, squared, plus k. The h comma k, remember, is the vertex, and that's what we're in search of in this problem. So to write it in vertex form, I need to have a vertex. I can supply the a right now because it says right here that a is 2. So I'd like you to write y equals a, replaced with a 2, sorry about that, times x minus something squared plus something. We're going to supply the h and the k by finding the vertex over here. So remember, you should have in your notes that the vertex is located on the axis of symmetry. To find the axis of symmetry, we use the formula that the x value is equal to the opposite of b over twice a. So I will need to take the opposite of a -5. Again, right here is your b, it's a -5. The opposite of a -5 is 5 over 2 times a. In this scenario, a is a 2. It's this right here. So 2 times 2 is 4. So I get 5/4, or if you're allowed to round, 1 1/4, or 1.25. That is the x coordinate of the vertex. In this scenario, it's this guy right here. So I say 1.25. To get the y coordinate, I take my x and I plug it in. So you'll need to get a calculator. I'm not going to supply this answer. I'll walk around and make sure you fill it in for those participation points. So make sure that you go grab a calculator. If you need one, ask me. Just pause the video. You need to do 2 times the x value squared minus 5 times the x value, should show all this work, plus 12. Then you'll go to a calculator, do it. Raise your hand and I'll come check it before you move on. Whatever you get there, it's going to go right here. And this will be your answer. So I'm going to repeat that process because it seems like I did a lot, but there wasn't a whole lot. They gave me the form of the parabola in standard form. They asked me to write it in vertex form. In order to do that, I needed the vertex. I was able to supply the a because it said 2, so I was able to put that 2 in right there. But I needed to figure out what's the h, what's the k, meaning what's the x value of the vertex and what's the y value. To get the x value, I used the formula opposite of b over twice a. I grabbed those numbers from up above. It was the opposite of -5 over 2 times 2. I made that a 1.25, and it went in right here for the x value of the vertex. Then to get the y value, all I did was plug the x in to the model. And I had to use a calculator. I don't know what that is, but you should go grab a calculator, and it's done. The next one, again, feel free to pause at any time to get caught up. This one, it said to graph it. It gave you the vertex. Whenever you need to graph, the vertex is the key. It's either the highest or the lowest point on your graph, because vertexes can only be maxes or mins. So I know that I have either a max or a min up at 2, 3. That's either the highest or the lowest that the parabola gets. The other point that it goes through is 6, 9. So I'm going to go 1, 2, 3, 4 out to 6, then 3, 4, 5, 6. Again, you should be on graph paper 7, 8, 9. And at 6, 9, I have another point. Now, what that tells me is that this vertex right here at 2, 3 was the minimum, which means I have another point symmetrically on the other side. Keep in mind, I went 2, 3, 4, 5, 6. So I went over 1, 2, 3, 4. So if I go back 1, 2, 3, 4, right? And that'd be from 2. I'd be at -2. I have another point at -2 that's at the same height. Because remember that axis of symmetry is the splitter. So the key to these is to get your vertex on your graph. It's either the highest or the lowest the graph gets. The other point will tell you that, because if it's above it, it means this must have been the minimum. If they had said it went through like 4, -1, I'd know that that had been a maximum and I would have come around like this. So nice and easy in that section to graph them. Once you have the vertex and another point, just plot it out. 43 is a word problem that gives you the model of a height of a certain object after a given time. And it says find the time. So I'm looking for the t here. This is equivalent, by the way, to y equals 16x minus 16x squared. It's just that in this scenario, our x-axis is time, and our y-axis is giving us our height, and something's going up and then coming back down. I want to know how much time it took to reach its maximum. So really I'm looking for the x-coordinate of the vertex. We're going to call it the t-coordinate because t is our independent variable down there, but I would say that the x-coordinate of the vertex is equal to the opposite of b over twice the a. You need to go supply those numbers from this model. Remember, it goes a x squared plus bx, plus c. So the b is what's in front of the lone x term. In this case, it's a 64. Okay, you might say, but there's a t. It doesn't matter. It's just interchangeable variables. So that would be the opposite of b. A is what's in front of the squared term, which would be a -16. So over twice -16. That'd be a -64 over a -32, which gives me a +2. So the time that it takes to reach its highest point would be at t equals 2. And I don't know if this was in seconds or minutes. I'm assuming it was seconds, but I'll just say at t equals 2. That's the first part of the question, the time it took to reach its highest point. That means that it reached its highest at 2 seconds. So that would be like if this was at 2. The next question is, how high did it get? Well, that's the y value. I want to know what's the y value of the vertex. And to get the y value, I just plug this in. And again, the y-axis is representing height here. So I'm really saying to find the h value, I plug t in. But always when you find a vertex, the first coordinate is opposite of b over twice a. The second one is found by plugging that into the given model. So I'm going to plug the 2 in to the given model. The maximum height will be achieved at 64 times t, but t is 2, minus 16t, which is 2. And you'll have to go do that. I'll have you supply the highest point. So h equals, you supply it by using a calculator. Got to make you do something on these, right? So you go supply that off your calculator. And then the last one I'll do for you, and when you're done with the whole sheet with these 4, just show me. And I think we'll do our daily participation points based on what you can show me at the end of the hour. I think that'll be a good way to do it. So on the last one before you go fill in the missing gaps, obviously I'm not doing all of them, but I got a few more to do. Number 45, I'll give you a little bit of time here to write it down. Number 45, I'm given y equals And if we're to talk about forms, this is in vertex form. So a little review coming at you right here. I want you to just write that down. Again, these are directions in the book. You don't really need to write that down. I just don't have the book copied up here. So there's my parabola. I know it's a, let's do a little review here. I know it's a parabola because of that squaring right there. If it had absolute value bars like this, we'd know it makes the V. Without either of those things, just y equals x minus or plus 4, that's a line, absolute value. This indicates a quadratic, which means we're going to get a parabola. Your parabola will open up or down based on what's in front here. Because this is positive, it's going to open up. The vertex is at 1, 2. So I know it opens up from 1, 2. That's a really loose graph of the parabola. I'm being asked to find the y-intercept. The y-intercept is where it hits the x-axis. I want to know what is that. The key to these is to know that wherever something hits the x-axis, be it here, here, or the y-axis, I mean here, here, the x value is 0. Like this would be 0, 1, 0, 2, 0, negative 3. But x is 0 when we hit our y-intercept. So I'm in search of what do I get when I put a 0 in for x. That's really all this is saying. A very easy problem if you know what a y-intercept is. So I'm going to repeat that. The y-intercept is where it hits the y-axis. When anything hits the y-axis, no matter what it is, its x-coordinate is 0. So this is 0 over 5 up, so I'd call 5 the x-intercept. So to find it, I want to know the y value when x is equal to 0. It's as easy as that once you understand what a y-intercept is. It's where it hits the y-axis, and that means x, the left-right motion, has to be 0. That'd be y equals negative 1 squared plus 2. That would give me y is equal to 1 plus 2, or y equals 3. So my y-intercept is at 3. Now remember at the very beginning, so before you have me look at these, what I would like you to do is go back and put that cheesy graph on here. I said its vertex was at 1, because there's the minus 1, comma 2. I also said that I knew that this opened up because there's a positive in front of here. When you don't see it, it's positive. And so I know it opened up. So I know my parabola looks like this. We just mathematically said that the y-intercept right here is 3. Doesn't that look good? Even on a graph that's not on graph paper, my answer is jiving with what I know about the graph of a quadratic equation. So that's it. To get your participation points for today, you just show me that you're done with those and continue working. So I'm going to start giving, I think 3 participation points a day I'll try to do when I can think of it. 2 will be for doing what we do, and the other one will be from continuing to work on the assignment. Or if it's done, you can just show me and sit and chat. So if you were already done, I don't want you to lose this point. That wouldn't be fair. But the first 2 points for doing it, and then the last point for continuing to work until 2:08. Peace out, Girl Scout. Have a good one.